Hi kids. So today we will solve this exercise 1.2 of maths NCRT of class 10. So the first question is, prove that root 5 is a rational number. So we can prove that root 5 is a irrational number by first assuming the contradiction of this. That is, let's assume that root 5 is a rational number. So if we consider that root 5 is a rational number, then there exists two integers a and b such that root 5 is equal to a upon b, where b is not equal to 0. Also we assume here that a and b are in its lowest terms. GCD of a comma b is 1. It cannot be divided further. A upon b is in its lowest form. It cannot be divided further. Now we square on both the sides. So 5 root 5 square is 5 is equal to a square upon b square. So 5b square is equal to a square. So this means a square is divisible by 5. So a is divisible by 5 since 5 is a prime number, and if a prime divides a square, it must divide the number itself. So we can write a is equal to 5k. Now a square we can write as 5k square, which is 25k square. 5b square, here b square is equal to 5k square. Now as per this statement, b is divisible by 5, right? So as per this statement, b is divisible by 5. Now we have both a and b divisible by 5, which contradicts our earlier assumption that a by b is in its lowest form. So this is a contradiction, and hence root 5 is irrational number. Hence proved. Now next question. Now the next question is that 3 plus 2 root 5 is irrational number. We need to prove this. So again we will assume that 3 plus 2 root 5 is a rational number. So 3 plus 2 root 5 is equal to r. Let's assume this, where r is any rational number. Now subtracting, bringing this 3 here, 2 root 5 is equal to r minus 3. Root 5 is equal to r minus 3 upon 2. So here this, as we already know, we have already proved in the earlier question that root 5 is a irrational number, and hence this should be irrational too, which is against our assumption. So this should be irrational. Since 2 is a rational, 3 is rational, this should be irrational. R is irrational. It implies, this thing implies that R is irrational, but actually R, we had assumed that R is a rational number. Here we are getting that R is an irrational number, which is a contradiction, and hence our assumption is wrong. So 3 plus 2 root 5 is actually a rational number. Now question number 3. So here question number 3 is prove that the following numbers are irrationals. So here we have 3 numbers that we need to prove are irrational. The first number is 1 upon root 2, second number 7 root 5, and third is 6 plus root 2. So to prove all these 3 parts of the same question, where we need to prove that these are irrational numbers, we will assume the opposite, the contradiction of it. We will assume that these are rational numbers. So first part is 1 upon root 2. So let's assume that this is a rational number. So if it is a rational number, then it can be written in the form a divided by b. Now, where a and b exist in its lowest forms, so root 2 is equal to b upon a. Because root 2 is irrational, so this is also irrational, which is which we have assumed that this is a rational. We had assumed that this is a rational number. Now this is a contradiction to our assumption. Hence 1 upon root 2 is irrational. What we have assumed is wrong, that it is rational. Hence it is irrational. Now the second part is 7 root 5. 7 root 5. So let's assume that 7 root 5 is a rational number. Hence it can be represented in the form 7 root 5 is equal to r, where r belongs to some rational number. Root 5 is equal to r upon 7. Now since root 5 is irrational number, we have already proved in our earlier question, this is supposed to be irrational too, which is against our assumption that it is a rational number. R is a rational number, and hence this is a irrational number. 7 root 5 is a irrational number. Now third part is that we need to prove that 6 plus root 2 is rational. Let's assume 6 plus 2 is rational. So 6 plus root 2 can be shown as r. Now root 2 is equal to r minus 6. This is a irrational number, hence it should be irrational too, which is opposite to our assumption that it is a rational number. So our assumption is wrong, hence prove that it is a irrational number. Please like and subscribe this channel, Class at Bits, for more such videos, educational videos of class 10th mathematics. Thank you.